All right, welcome guys. Quick crash course on how to calculate out the distance to epicenters using Earth Science Reference Table page 11. Okay, so take a look here. I have Earth Science Reference Table page 11. You've got your P wave and your S wave curve. You have the bottom part on here, which it says epicenter distance. It's times 10 to the third, which basically means each one of these is 1,000 multiplied by 1,000. So this point right here, that would be your 1,000. That right there, this would be 2,000 kilometers, 3,000, and so on. On the left-hand side, you have travel time in minutes. Now, the nice thing about this is that they give you subunits. The subunits for these are 20 seconds. So that would be 0. That would be 0 minutes and 20 seconds. That would be 0 minutes and 40 seconds. That would be 60 seconds, also known as 1 minute. So 120, 140, 2. 220, 240, 3. So I like to write on the side, subunit is 20 seconds. And then on the bottom, I like to write subunit is 200 kilometers. Because if you take a look here, if that's a 0, and that's 1,000, 200, 400, 600, 800, 1,000. All right. So I'm going to start us off on today's activity by doing a little bit of math. We're going to have to subtract some time. Remember, the process always goes from S wave, take away P wave. S wave says 10, 02, 00. P wave is 10, 00, 10. 0 minus 10, can't do it, got to borrow. 02 becomes 01. We're going to drag over 60 seconds. 60 seconds plus 0 seconds is 60 seconds. Now, that's not always going to be 0, so you might have to add something to the 60 that you're going to drag over. But you will always drag over 60. 60 minus 10 will give you 50. 01 minute minus 00 minute equals 01. 10 hours, take away 10 hours, is 00 hours. That gives us a P wave, S wave lag time of 00 hours, 01 minute, 50 seconds. Next, we need to calculate out our epicenter distance. So doing this is relatively simple. You're going to take a scrap piece of paper, and you're going to line it up along the y-axis. Start off by marking your 0 on the y-axis, and then mark the number that you measured. So here we said it was 1 minute and 50 seconds. Well, if that's 1 minute, that would be 120, 140, 160, also known as 2. So just below the 2 would be our 150. So this is 1 minute, 50 seconds. Next step, you're going to slide this paper while holding it vertical along the chart. Now you'll notice we have our P wave and our S wave lines. You want the bottom line that you created to touch the the P. And you want the top line to touch the S. So you'll notice I'm holding my paper very straight here. If I follow it straight down, I end up right on the 1,000 mark. Right? Sorry, we're at the 1,000 mark. So I know that my epicenter distance is 1,000 kilometers away. Oops, there you go, 1,000 kilometers away. Next, I need to calculate P wave travel time. And this is very simple. All you got to do is find your 1, carry it straight up until you bump the P line, and then you're going to move across. So that looks like it's just above the 2, so I'll call that 2 minutes, 10 seconds. 0, 0, 0, 2, 1, 0. And finally, we're looking for our S wave travel time. Again, since our distance is 1,000, we're going to go up, 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 bump the S line, and then go over to the left. It says it's 4 minutes, so that is the same as 0, 0, 0, 4, 0, 0. For today's activity, I'm going to ask that you leave origin time blank. We do not need to do that. And I do not want you to describe the location of the epicenter or the plate boundary. We're going to be learning about this tomorrow and some other days. So that is what this paper should look like. What you need to do is complete these 4 boxes and these 4 boxes. I'm going to ask that you please make sure that this is turned in at some point this evening. Thank you.